Saptagiri. YouTube www.youtube.com/c/dd Saptagiri. మా కార్యక్రమంపై మీ అభిప్రాయాలు తెలియజేయగలరు. ఈమెయిల్ ddsaptagiri@gmail.com, ఫేస్బుక్ www.facebook.com/ddsaptagiri, ట్విట్టర్ twitter.com/ddsaptagiri-vja, ఇన్స్టాగ్రామ్ www.instagram.com/ddsaptagiri, యూట్యూబ్ www.youtube.com/c/dd Saptagiri.
Good morning. Welcome to Vidyamrutham program. This is Komineni Madhusudan Rao, physical science teacher. Today we are going to see one of the important chapter in physical science is carbon and its compounds. So in this chapter, we will see some important points. So the main point is versatile nature of carbon. Here the versatile nature of carbon is, we know most of the carbons are ability to form a bonds with the other elements like oxygen, nitrogen, sulfur, etc. And also these are exhibiting hybridization and catenation properties. In hydrocarbons, alkanes, alkenes and alkynes are there. Nomenclature is also we are going to watch in this chapter. Next another one is isomerism. Next functional groups. Some chemical properties of alkanes, alkenes and alkynes are combustion, oxidation, addition and substitution reactions. And some preparations are also there here: ethanol, ethanoic acid and esterification. Next one, soap and saponification and micelli also we are going to watch in this lesson. Next, first one, atomic number of carbon is C. Here you observe the basic configuration is 1s2, 2s2, 2px1, 2py1 and 2pz0. But in this excited state electronic configuration, the electron from 2s2 enter into the 2pz, that is excited state configuration is 1s2, 2s1, 2px1, 2py1 and 2pz1. So it is having a 4 electrons in the outermost shell, that is called valency electrons are 4 and valency is also 4. Here the valency is 4 means it is ability to form a 4 bonds. So these 4 bonds are having 4 single bonds on carbon atoms either side of the 4 sides of the carbon atom, and next one side double bond, another side 2 single bonds, and one side triple bond and another side single bonds, and 2 sides double bond is also you are observing. Some examples in this case, here 4 single bonds with hydrogen or methane, and halogens are chlorine, carbon tetrachloride you are observing here, and also carbon is forming a bond with bromine, chlorine and also 2 more hydrogens are you are observed here. Next one, double bond of and 2 single bonds. Carbon is having 2 double bonds on either side, and one side one more is example is carbon dioxide, and one side double bond, another side 2 single bonds are there. Next, one side triple bond and another side single bonds, that is HCN you are observed, and one more example is here acetylene. So, all are different examples for 4 single bonds and one side double bond and single bonds, 2 side double bonds and one side triple bond and another side single bond. Next, one more important concept in this carbon chemistry is hybridization. So, what is the importance of hybridization means here while forming the bond formation, the bond strength and bond angle is not explaining with a valency bonds theory, but in this theory while bond formation both s orbitals and p orbitals are combining, they form some new orbitals. Here we are going to see the phenomenon of intermixing of orbitals, and again they are redistributed into equal number of orbitals having same shape and energy. So, therefore, they are called as a hybridization, and this orbitals formed are called hybrid orbitals. Next one, in this after that one example we are going to see for sp3 hybridization, we are going to watch CH4 formation, that is methane. In case of methane, sp3 hybridization. What is sp3 hybridization means? One s orbital and 3 p orbitals, that is 4 orbitals are intermixing and they are redistributed into 4 sp3 orbitals, each are having a single electron. So, this just you observe this diagram here. In this one, a carbon is a central atom and put 4 sp2 orbitals on 4 sides, and this each carbon atom sp2 orbital form a bond with the hydrogen atom. Therefore, we are observing 4 sp2 s bonds are there here, and the bond angle between HCH is 109 degrees 28 minutes. Next one, for sp2 hybridization, we are watching here now C2H4, that is ethene or ethylene. Here sp2 hybridization, one s orbital and 2 p orbitals, that means totally 3 orbitals are intermixing and they are redistributed into 3 orbitals of equal energy and shape. That means 3 sp2 orbitals are available here. In this 3 sp2 orbitals, they are forming bond with the like this way. In this diagram, both the carbon atoms are there. Between carbon and carbon, sp2 hybridization, that is sigma bond is there, and left side carbon is also forming 2 more sp2 s bonds with the hydrogen. Right side carbon is also forming 2 more sp2 s bonds with the another right side carbon, and both 2p z orbitals of both the carbons, they form a side over side bond, that is the pi bond is observed here. One pi bond and the remaining 3 sigma bonds are there in this acetylene. Next one, formation of acetylene, or this is also called ethane. Here sp hybridization is we are observing here. In this sp hybridization, one s orbital and 1 p orbital combine to form a 2 orbitals, again they are redistributed into 2 sp orbitals. Each sp orbital is bond forming with the another carbon. Just you observe this diagram, one carbon from left side, another carbon from right side, that is sp hybridization is there. And next one, left side one more sp is with the hydrogen, right side carbon another sp is with hydrogen, and here that means sp and sps, these are sigma bond. Next, blue color and pink color you are observing, 2py and 2pz of both the carbon atoms are they are forming with the both 2 pi bonds. Here in this case acetylene, out of 3 bonds, first bond is a sigma bond, middle one between carbon atoms, remaining 2 bonds are called pi bonds. Next one, allotropes of carbon. So, what is allotrope? So, the compounds exhibit different physical forms having similar chemical properties and different physical properties. So, in case of allotropes of carbon, the 2 types of there, one is amorphous form. In this amorphous form, we are going to see some examples, that is coal, coke, wood charcoal, animal charcoal, lamp black, gas carbon, petroleum coke, sugar charcoal. Here Coal is already, we are already digging from the earth crust, and it is on heating, it releases coal gas and formed a coke, and also lamp black. So while lighting a candle, it forms some black color on the walls, that is called lamp black. And also here sugar burning, wood burning, they are also producing here amorphous forms, they are not having definite structure. But second one is crystalline forms. These crystalline forms are example diamond, graphite and Buckminster fullerene. Carbon atoms can arrange themselves into different hybridized chemical bonds, exhibit different physical and chemical structure. Here these are having definite bond length and bond angle, and like this, just we are watching here now diamond. In this diamond, like methane, sp3 hybridization is there. Each carbon atom is forming 4 bonds with the other carbon atoms. It is a tetrahedral 3D structure, and strong and hardest one of the universe, and shiny due to lower critical angle, that is 24.4 degrees. Another crystalline form is a graphite. Here it is also in graphite is also sp2 hybridization is there. So these are forms a layer. So one layer is having hexagonal carbons are there. Each between the bond length between the carbon and carbon is 1.42 angstrom units, and the bond angle is 120 degrees. Here one layer is overlapping on another layer, between layer and layer, so some weak attractions are there. So the bond length between one layer and another layer is 3.35 angstrom units. Next, Buckminster fullerene. So these are also called fullerenes. Fullerenes are formed when vaporized carbon condenses into inert gas atmosphere depending upon their orientations. These molecules form halospheres, ellipsoid and spherical shape depending upon the number of carbon atoms. But Buckminster fullerene is having 60 carbon atoms are there. Here you observe the 3 diagrams, that is the diamond is having a tetrahedral structure, graphite are having some layers, and next Buckminster fullerene is C60. It is having a 32 closed structures, 5 pentagonal structures are 12 and hexagonal structures are 20. So these are the examples of crystalline form. But so one more is the graphene. So this is recently find out here 1 mm thickness of a graphite nearly having a 3 lakhs layers of graphene. So it is a each graphene layer is having 0.3 nanometers of thickness. It is a highly transparent to light and conducts electricity better than copper, and is 200 times stronger than but 6 times lighter than steel. Next, nanotubes. So this graphene is folded in the form of a cylindrical forms. Here you observe the diagram consists of hexagonal layers. So these are cylindrical form structures. So they are rolled in the form of a cylinders. These are used in electrical conductors and molecular wires in integrated circuits. Medicine also used instead of copper to connect the components together. Next one, it is also one of the versatile nature of a carbon. So what is the versatile nature? దీన్నే మనం బహుముఖ స్వభావం అని చెప్తాం. ఈ బహుముఖ స్వభావం అంటే ఏంటంటే ఎక్కువ మూలకాలతో ఇది బంధాలని ఏర్పరచుకునేటటువంటి అవకాశం ఉంది. The ability to formation of self-linking bonds and bonds with other atoms containing millions of carbon atoms having long branched and cyclic structures exhibiting versatile nature of carbon. So example, here you are observing due to this nature of it occupies several feeds like a food. In food, that is carbohydrates, proteins, nucleic acid, lipids, vitamins and hormones, etc. And in medicine, drugs and vaccines are also prepared by using a carbon, and clothing, cotton and silk are also there in the carbon. Next, fuels, natural gas, petroleum, LPG and CNG. So in our home, generally we are watching LPG. LPG is containing the one of the alkene, that is butane is the major component in that one, and natural gas is also one of the best fuel. Next one, CNG is used in autos and buses are also there. Some artificial fibers, they are called plastics, rubber, etc. They are also having a carbon. Next, catenation. An element forms a bond between its own atoms to give big molecules. That means unlimited number of carbon atoms. So, they are combined to form a long chain compounds, and a large number of carbon atoms are here formed. In this case, single, double and triple bonds are also there in this structures, and some more non-metals are also there. Oxygen having maximum number of oxygen atoms are 3, that is ozone. Sulfur is also having rhombic sulfur, monoclinic sulfur, like this. Up to 8 sulfur atoms are combined to form a molecule, and in phosphorus maximum 4 phosphorus atoms are combined to form a P4, that is white phosphorus, and red phosphorus is also there here now. Next, here one more important hydrocarbons you are observing. Hydrocarbons means the compounds formed by carbon and hydrogen are known as hydrocarbons. So, these hydrocarbons are classified into 2 groups depending upon their open chain compounds and also closed chain compounds. So, these closed chain compounds are again classified into alicyclic and aromatic. Alicyclic are called cycloalkanes, generally cyclobutane, cyclohexane. So, these are also having a formula, general formula like alkenes, CN, H2N, and aromatic are the benzene compounds, benzene, toluene, xylene. So, these are the aromatic compounds. Regarding aliphatic or open chain compounds, depending upon the bonds between the carbon atoms, if all are single bonds are there between the carbon atoms. So, here these are called as a alkanes. So, these alkanes are also called as a paraffins, and general formula of alkanes is CN H2N plus 2. Next one, unsaturated hydrocarbons. These unsaturated hydrocarbons are 2 types. First type is alkene, second type alkynes. Alkenes are also called olefins, alkynes are also called acetylenes. Here, if any one double bond is there between any 2 carbon atoms, they are called alkenes. The general formula for having a one single bond between any 2 carbon atoms, therefore, that is CN H2N. If one triple bond is there between any 2 carbon atoms, we call that the general formula is taken as CN H2N minus 2. Next one, homologous series. So, this homologous series, the series of compounds in which 2 successive compounds differ by CH2 unit are called a homologous series. Swalpa viramu. In this homologous series, some examples are, we may take alkanes, alkenes and alkynes, alcohols, aldehydes, carboxylic acids. So, these are all examples for homologous series. So, in detail we are observing this table. N alkanes, their general formula is CN H2N plus 2. The gap between 2 successive compounds is CH2, that is methane is CH4, next C2H6, C3H8, like this way. Next, alkenes general formula CnH2n, and all the same time cyclic alkanes are also CnH2n. Next, alkynes primary alcohols, next mono carboxylic acids. So, these are also examples for the homologous series. One more important aspect in this one is isomerism. Compounds having same molecular formula but different structures are known as isomers, and the property is called isomerism. అంటే ఇక్కడ ఒకే అణు ఫార్ములా ఉంటుంది బట్ నిర్మాణం మాత్రం వేరువేరుగా ఉంటుంది. So, if a builder is having same material, he may construct different shaped building. So, like that way in hydrocarbons also having several isomers. One example is butane. Butane is having 2 isomers, they are N-butane and isobutane. So, N-butane means 4 carbon atoms are in a same chain and all hydrogen atoms. If 3 hydrogen atoms are, if 3 carbon atoms are in one direction and the branch is taken from second carbon, that is called isobutane. Pentane is also having 3 isomers, normal pentane having 5 carbon atoms in a parent chain. Next, isopentane, 4 carbon atoms having 1 branch, and neopentane, 3 carbon atoms having 2 branches. Here these are the isomers of butane and pentane. Next, binding of carbon with other elements. Carbon forms compounds not only with atoms of hydrogen but also with atoms of other elements like oxygen. So, what is oxygen? So, we are breathing oxygen day to day life. So, it contains the carbon and oxygen, and at the same time nitrogen is also there. Nitrogen is also having a cyanogen bonds, and sulfur is carbon disulfide, phosphorus is P2O5 and P2O3. Next, halogens. So, these halogens are here you are observing carbon compounds with CHX. Here X is indicating halogens, that is chlorine, bromine, iodine. So, one example is methyl chloride. Here what is methyl, ethyl, propyl, butyl. So, these are simply indicated with a letter R or R dash or R double dash. Here methyl chloride, ethyl chloride, propyl chloride, like this ethyl bromide. So, these are all compounds of with hydrogen and halogens. Next, carbon compounds with hydrogen and oxygen. Here you observe the 3 structures. The first structure is having carbon is linked with one side oxygen with the double bond, another side 2 hydrogens are linked with single bonds. It is by taking CHO, that is the aldehyde group. If another bond is also H, this is called formaldehyde, this is also called methanaldehyde, and it is also called methanol. Next, if one hydrogen is replaced by alkyl group, that is CH3, we call that is called as a also aldehyde, acetaldehyde. This is also called ethanol. Next, the third structure is if both the hydrogen atoms are having alkyl, they are same or different, therefore that is CH3, CH3. If both hydrogen are replaced by the alkyl group, that is simply called as a ketone. Here the basic ketone is the acetone, that is also we call propanone. Next one, carboxylic acids. The general formula of carboxylic acids are RCOOH. Here R is alkyl group, and just observe the first one is a methanoic acid, that is HCHO. Instead of HA, if we will take one alkyl group, that is CH3, that is ethanoic acid. If two CH3 and CH2 is attaching with the COOH, that is called propanoic acid. Next, alcohols, general formula is R-OH. Observe methyl alcohol, ethyl alcohol, propyl alcohol, like this. Next, ethers. So, these are carbon compounds related to H2O in such a way that both the hydrogen atoms are replaced by 2 alkyl groups. So, these are which may be same or different. You observe the diagram, left side is the water, oxygen is linked with the 2 hydrogen atoms of covalent bond. If one hydrogen atom is replaced by alkyl group, that is R-OH, and alcohols are formed. If 2 hydrogen atoms are replaced by alkyl group, so they are formed as a ethers. See the example, general formula of ether is R-O-R- and it is dimethyl ether or methoxy methane, and second one is methyl ethyl ether. Esters. So, these esters are these compounds are the derivatives of carboxylic acid. So, general formula of carboxylic acid is R-COOH. If H is replaced by the alkyl group, that is R-COOR. Therefore, that is called ester. Here you see the one example, double bond side one CH3 is there, that is called methyl ethanoate. If double bond side one C is there and two more CH2 and CH3 are there, right side with O, therefore that is ethyl group, ethyl propanoate. Compounds bond with the carbon, hydrogen and nitrogen. Here ammonia means nitrogen is linked with the 3 hydrogen atoms, depends upon the substitution of alkyl group. So these are formed as primary amines, secondary amines and tertiary amines. If one hydrogen is replaced by one R, that is called alkyl group, primary amine. If 2 hydrogen atoms are replaced by alkyl group, they are called secondary amine, and third one as 3 hydrogen atoms are replaced by alkyl groups, they are called tertiary amines. Now we are going to watch IUPAC nomenclature. So in this IUPAC nomenclature, so first one is functional group. What is functional group? Atom or group of atoms, they are responsible for the properties of whole compounds. We called as that is a functional group. Depending on a functional group, the properties will be changed. Here you see the order of functional groups. So the first is carboxylic acid, ester, aldehyde, ketone, and next one alcohol, amine, ether. All the pink color, that is called oic acid, O8 for ester, Al for aldehyde, One for ketone. So these are all indicating secondary suffixes if a single functional group is there. Otherwise, suppose if any 2 functional groups are there in this order, so the first one is taken as the secondary suffix, the remaining all are taken as secondary prefixes. In that case, the black color, that is oxycarbonyl for ester, and aldehyde is taken as secondary prefix is formyl, ketone taken as a oxo. Next one is here alcohol, if it is a secondary suffix, that is -ol, it is taken as a secondary prefix, we have take hydroxy. Similarly amine also, this is amine for secondary suffix and amino for secondary prefix. Ether is also one more functional group. Here the just you follow the priority order of considering the functional group. First we are going to give the importance for the functional group to select a parent group. So here if there is no functional group, we will consider En. So therefore that is En is the double bond, and if double bond is not there, next we will consider triple bond. If these 3 are not there, so therefore that is we have to consider these 3, that is functional group, En and Yne are not there, we will consider long chain having a side chain, more side chain substituents. Here R, R dash, R double dash are the alkyl groups. Next Sp indicates secondary prefix, Pp indicates primary prefix, Wr indicates word root, and Ps indicates the primary suffix, and Ss indicates the secondary suffix. So see this diagram and watch this here now. Here we are going to watch just one table is there. First at the number 5, word root. So word root always while naming, first you have to consider the word root, that is word root means consider count the number of carbon atoms here 1, 2, 3 like this way. First you write the after counting, that is the word root name, oct is there, 8 carbon atoms are there. After that here functional group and double bond and triple bonds are there. Here this name is oct 3 1 oic acid. So therefore here always you consider the word root having a functional group. So next one after considering right side of word root, we will take double bond and triple bond. After that double bond and triple bond, we will take the functional group. Left side we will take a primary prefix at the number 4. This primary prefix are may be taken as a only for cyclic compounds, and next before the primary prefix, we will take SP, that is called secondary prefix. Here we will see one example, long chain rule or lowest number rule. Here the number of maximum number of carbon atoms in the long chain are 6, and also lowest number rule, that is methyl is the one of the secondary prefix. This methyl is from actually counted from 1, 2, 3, it is from third carbon. If it is counting from other side, methyl group is at fourth number. So the lowest number rule we must follow. Here 6 carbons are there, because of that word root is hex, all are single bonds AN, and all are hydrogens and compounds, we have to take E, and third carbon is having a methyl group, that is called CH3. So therefore its correct name is 3-methyl hexane. If more side substituents are present, we will consider the lowest sum. Here just observe the diagram. Here 7 carbons are there in long chain, that is hept, all are single bonds AN, all are hydrogens and carbons, we will take E, and third and fourth is taken as a correct structure for dimethyl. For suppose if you consider 4 and 5, 4 plus 5 is 9, that is the wrong notation. 6 carbon atoms are there. After that in third carbon having a OH, fifth carbon is having hydroxy. So its name is by considering aldehyde, that is hex, right side AN and Al for CHO, are the remaining two, that is called ketone and OH. These are 3-hydroxy 5-oxo. Here we must follow alphabetical order, that is H comes before O. Next, draw the structure of 3-propyl pent 4-YN 1-oic acid. In this case, first what is the word pent means you have a 5 carbonates, and fourth carbon contains IN, and first carbon is oic acid. From oic acid, after fourth carbon you will take a triple bond, and third carbon from carboxylic acid group side, third carbon is having a propyl group. That is first you select word root, then functional group, then triple bond, after that secondary prefix. This is 3-propyl pent 4-ine 1-oic acid. But here long chain is having a 6 carbon atoms, but we have to consider triple bond, we will take 5 carbon atoms as a parent chain. If 2 equal number of long chains, we will consider which is having maximum side chains. Observe the example, 5 carbon atoms are there, and second carbon atom 1-methyl is there, and also third carbon atom is having a ethyl group. It is a 3-ethyl 2-methyl pentane. One more example, if 2 or more prefixes are there, we should follow the alphabetical order. Ethyl comes before methyl. So therefore its name is 3-ethyl 5-methyl octane. That is 8 carbon atoms are present, 2 functional 2 secondary prefixes are there. Ethyl is taken as a first and methyl is taken as a second one to follow the alphabetical order. Next, chemical properties of carbon compounds. So you know combustion reaction in our daily life. What is combustion reaction? The reaction between the carbon compounds and oxygen, that is called carbon dioxide. Alkanes react with oxygen to form a carbon dioxide, and similarly alcohols are also react with oxygen to form a gives carbon dioxide and water. At the same time they give more heat and light. Because of this, these are used as fuels. Next one, oxidation reaction. Generally oxidation reactions we will consider combustion reaction is oxidation reaction, but all oxidation reactions are not combustion reactions. Removal of hydrogen is also called oxidation reaction. Here you observe from ethanol, in the presence of potassium dichromate, it is converted into forms as a acetaldehyde. After that it forms acetic acid. Next, addition reaction. So these addition reactions taking place only in case of unsaturated hydrocarbons. So they are alkenes and alkynes. Alkenes are having a double bond. They are added with one hydrogen atom in the presence of catalyst nickel. So, they form a ethane. Here example is ethene is react with hydrogen, forms ethane. And also if acetylene is there, two H2s are react with the acetylene, finally they are also formed ethane. Substitution reaction. So, these substitution reactions taking place in alkanes, a reaction in which an atom or group of atoms in a given compound is replaced by other atom or group of atoms is called substitution reaction. They are called chemically least reactive. Here one example is C2H6. Ethane is reacting with the chlorine in the presence of sunlight, it forms a chloroethane. One more example. If CH4 plus Cl2 gives CH3Cl plus HCl. Here hydrogen atom from methane is replaced by the chlorine of highly reactive, it forms a chloromethane. Again this chloromethane react with chlorine, it forms a dichloromethane, and dichloromethane react with the chlorine, it forms a trichloromethane, it is also called chloroform. Next one is CHCl3 plus Cl2, that is tetrachloromethane is also observed. So, these are all substitution reaction followed by the alkanes and alkenes. Next, esterification, RCOO R dash. Here R and R dash are alkyl groups. The reaction between carboxylic acid and an alcohol in the presence of concentrated H2SO4 to form a sweet ordered substance, ester with the functional group is called esterification. So, just you observe the reaction, bottom reaction, one is the acetic acid, second one is the alcohol. Here in acetic acid, one hydrogen from acetic acid and OH from alcohol, these two are formed a water, and that C2H5 is substituted in the place of hydrogen in acetic acid, that is CH3COOC2H5. Next, soap or saponification. Soap is a sodium or potassium salt of higher fatty acids like example palmic acid, that is C15H31COOH, and stearic acid C17H35COOH, oleic acid C17H33COOH. Formula of soap is RCOONA or RCOOK. Here R is indicating C15H31 or C17H35. Next, fats are esters of higher fatty acids, and trihydroxy alcohols are known as glycerol. Saponification reaction. Esters of higher fatty acids gives sodiums of higher fatty acids, that is called soap, and glycerol when heated with the sodium hydroxide, sodium salts of higher fatty acids are known as soaps. This reaction is called as a saponification. Just see here triesters are there, triglyceride, this is also called triglyceride. These react with the sodium hydroxide, forms a glycerol. So, what is glycerol? It is a propane 1,2,3 diol is called a glycerol. Here the next one is soap molecules are also observed here now. Instead of R1, R2, R3, if it is C17H35, we will observe the sodium stearate. Soaps are also good cleaning agents. Soap is an electrolyte. When soap is put into water, it gives a true solution. Above a particular concentration known as critical micelle concentration. So, the soap particles get aggregated, and these are colloidal size known as micelle or associated colloids. So, we know what is micelle means. While washing the clothes, some foam is observed. These foams are the aggregation of particles of soap. They are simply called as a micelle. Now, many questions coming from this carbon chemistry. Some of the questions are also you will observe in this model paper. That is, in model question paper, we have divided this model question paper half mark, 1 mark, 2 marks and 4 marks are there. Whole subject is just now we will see the one model paper. First one are half mark question. First question is, what is the value of latent heat of vaporization of water? This is the AS1 question from heat. So, it is latent heat of vaporization of water means 1 gram of water convert into vapor, it will take nearly 540 kilocalories of heat energy. Next, matching. Here the left side plaster of Paris, gypsum, baking soda. Right side CaSO4 to H2O and NaHCO3, CaSO4 of H2O. It is very easy to remember. Plaster of Paris formula is very easy to remember. Half is if you read half, that is CaSO4, half H2O is the formula. Next one is gypsum is CaSO4 to H2O. Baking soda formula is NaHCO3. Next, third question, if you cover lower half part of a convex lens, predict the nature of image formed. It is one of the hypothesis question. It is comes from AS2 question. What materials are required in an experiment to produce a rainbow in our classroom? It is a AS3 question. You will give the simply required materials, you will get half mark. Next, what is shape of p orbital? So, this is what is the shape of p orbital means simply you have to give the name of shape. It is also AS1 question. Next, you observe the table. Observing this table, we will have a 2 questions depending upon this table. Lithium is 7, sodium is 23, potassium is 39. Here sulfur 32 and tellurium is 125. Here the masses are given. Just you observe the question, what is the atomic weight of the element X? Once again you see the average of first and third of that is 32 and 125 will give the value of X. Next, what are these means? Question number, how do the given set of elements are called means they are nitrides. Take a test tube, pour some dilute HCl in it, drop some aluminum foil, which gas is released? So, this is also simple question. Here 9th question is joule by coulomb is same as. Here the it is work done to carrying a charge from one point to another point is called potential difference. Here the answer is 1 volt. This is also one of the AS1 question. Next, a conductor is passing into the page. So, what is the direction of current in the conductor? Here you observe this right hand rule. In this right hand rule, the current direction is inside the page. It is also AS2 question. Next, what is the name of the functional group? OH. So, many functional groups are also asked for the half mark question. Next, regarding 1 marks question, take 2 bowls with one is hot water, second one is the cold water and sprinkle the food color. So, the surface of due to the movement of the particles we can say the kinetic energy of the hot water particles is more. Next, here what is neutralization? Simply write the definition or you may give one example. Draw the virtual image by the completing the given figure. Here you have to, it is the within the focal length the object is there, the virtual image is formed on the same side. Next, 6th one, what are the maximum and minimum limits to change the focal length of eye lens? It is also from human eye and colorful world. 17th question, how do you appreciate the use of analysis method to understand the arrangement of electrons in an atom? This is a AX6 question. So, here this is the appreciation question. Why does chemical properties are similar to the elements in a group? So, here outermost configuration is also one of the important aspect in this question. You write the answer for this 1 or 2 points. Next, what do you mean by electric shock? Next one, name the carboxylic acid used as a preservative. Next one, for 2 marks question, here see the table and make them equal temperatures. After that equal temperature you may answer very easily, it is the AS4 question. Next one, in which city the morning temperatures at 6 AM are relatively high, and at what time to both the cities are having the equal temperature. If you convert the both of them into a Kelvin, it is answer is very easy. Next, your friend is asked to differentiate between evaporation and boiling. What questions could you ask to make him to know the difference between evaporation and boiling? Here why and what, which you will add, you will get the marks. Write a short notes on pH. Next, why pure acetic acid does not conduct electricity. How do you appreciate the ciliary muscles? And also Faraday applications here now suggest an highly reactivity. Here 4 marks question, explain the formation of rainbow, difference between convex lenses, explain Hund rule with example. Next one is AS4 question, that is 1s2, 2s2. Next one is here, this is from carbon chemistry. Here instead of R you put CH3 or C2H5 like this way. Aldehyde R dash CHO, it is called AL, R dash O dash, or it is ether, and amine it is R dash NH2. One example is RNH2, RCOH like this. So see, these two are also important questions now. So this is a very important lesson. If you have any doubts, so you watch the same lesson in Saptagiri-Govt. Thank you.
మా కార్యక్రమంపై మీ అభిప్రాయాలు తెలియజేయగలరు. ఈమెయిల్ ddSaptagiri@gmail.com, Facebook www.facebook.com/ddsaptagiri, Twitter twitter.com/ddsaptagirivja, Instagram www.instagram.com/ddsaptagiri, YouTube www.youtube.com/c/ddsaptagiri. పై మీ అభిప్రాయాలు తెలియజేయగలరు. ఈమెయిల్ ddSaptagirivja@gmail.com, Facebook www.facebook.com/ddsaptagiri, Twitter twitter.com/ddsaptagirivja, Instagram www.instagram.com/ddsaptagiri, YouTube www.youtube.com/c/ddsaptagiri.
లాక్డౌన్ సమయంలో అందుబాటులో ఉండే అత్యవసర సేవలు, నిత్యావసర వస్తువులను అందించే రేషన్ దుకాణాలు, ఆహార పదార్థాలైన పళ్ళు, కూరగాయలు విక్రయించే దుకాణాలు తెరిచి ఉంటాయి. అలాగే పాలు, పాల ఉత్పత్తులను అందించే డైరీలు, మాంసం, చేపలు, పశుగ్రాసం విక్రయించే కేంద్రాలు అందుబాటులో ఉన్నాయి.